Hey everybody, I am delighted to be participating in the 2020 Bat Advent Calendar. I know we're getting close to the 25th and towards the end of this amazing project. I'm Dr. Winifred Frick and I am the Chief Scientist at Bat Conservation International. And I've chosen a paper to talk about today called Insectivorous Bat Pollinates Columnar Cactus More Effectively Per Visit Than Specialized Nectar Bat, that I published in 2013, 7 years ago now, with a number of great co-authors. And I chose this paper today because at its heart, it's a story of two bats that love sugar and nectar. And it's the holidays, and I think we all love a little like sugary treats around the holidays. I know I certainly do, to fuel my holiday spirit. And so I'm going to be talking about how the love of nectar of these two different bat species creates an opportunity for mutualism and bats pollinating a plant. And so the tale of these two bats starts with the fact that we know that the lesser long-nosed bat is a species that is adapted for nectar feeding. It's an incredibly cool bat in that it's a migratory. It's one of the most northern ranging nectar feeding species, and it actually migrates across Mexico and into the southwestern United States, fueling its migratory journey on nectar, primarily from columnar cactus as well as agaves. And columnar cacti are adapted for bat pollination. They have big white flowers that open at sunset and then close the following morning. So they're only open primarily during the nocturnal hours, although sometimes they don't close down until mid-morning, depending on the species and the situation. And so we know that lesser long-nosed bats are the primary pollinators of columnar cacti, and Ted Fleming and others have done some really great work showing this really kind of classic mutualistic relationship between bats and cactus. And then the other bat that's in the story is the pallid bat, which is my personally favorite bat. And it is a species that is most well known for its habit of eating scorpions. It has really large ears that are very sensitive, and actually flies low to the desert floor, listening for the scuttly little sounds of scorpions and other large arthropods, and then it'll pounce on them and eat them. And it's known for the fact that it's immune to scorpion venom. So down in the Sonoran desert habitats of the Baja California Peninsula in northwestern Mexico, I actually worked on my PhD down there, looking at different bats that were on islands. And while we were doing that, we discovered that pallid bats actually love to come and visit these cactus flowers. And we were sitting out underneath the cactus and watching for the lesser long-nosed bats to come visit. And we noticed that in addition to lesser long-nosed bats visiting these flowers, that pallid bats were visiting the flowers. And that was a really unusual behavior, and something pretty exciting to watch and observe. And so we embarked on trying to understand a little bit more about this behavior, and ended up putting out a bunch of different types of cameras that we could set up so we could more closely film and observe this behavior, as well as quantify how many different visits per night pallid bats made versus lesser long-nosed bats. And on the videos, it's pretty easy to tell the bats apart because their morphology is really different. So lesser long-nosed bats have elongated faces, and they're adapted for nectar feeding. They have long tongues, long faces, and they are really good flyers, and they can hover in the flower. So they basically come up to a flower and they very quickly just, dip their head into the flower and use that super long tongue to get to the nectary, and then take right back off. Whereas the pallid bats are not physically adapted for nectar feeding. And so they do this super clunky thing where they fly up to the flowers and they actually grab onto the flowers and they plunge their heads deep into the flower, and then they lap at the nectar that's pooled up in the flower before they basically fall off the flower and then fly away. We were able to do some cool stuff where we could kind of cut a hole in the flower and film exactly, the tongues accessing the nectary, so we could tell that the pallid bats were actually lapping up the nectar. But what we also, with the focus of this paper that I'm talking about today, we really want to understand, could the pallid bats that are not adapted for nectar feeding morphologically, could they serve as a good pollinator for the cactus? Were they doing their job of moving pollen from flower to flower and actually pollinating the flowers? Or were they kind of like a nectar robber, right? Just sort of getting the sweet drink and going about their business and not doing any benefit to the cactus. So we designed a study where we would sit underneath the cacti and watch for either a lesser long-nosed bat to arrive and land on a flower, or a pallid bat to land and arrive on a flower. And as soon as we saw a bat arrive on a flower, we would climb up a ladder, because these cacti are really tall, and we would very carefully snip the stigma out of the flower. And then we would preserve it in a little Fuchsin jelly and put it on a slide, so that we could then later on in the lab, underneath a microscope, painstakingly count the number of pollen granules that an individual bat had delivered onto the stigma. And the basic short end of the story is that when we did that and we looked at all the data from a bunch of different places where we did this, it turns out that pallid bats actually deliver 8 times as much pollen per visit as the lesser long-nosed bats. So that comes out to be, on average, pallid bats deliver about 600 grains of pollen every time they visit a flower, whereas the lesser long-nosed bats visit about 75 grains. So pallid bats, partly because they don't have the specialized adaptation for kind of elegantly dipping their face and long tongues into a flower the way the lesser long-nosed bats do, because they're super clunky and they got to grab onto it and plunge their heads in, they actually end up depositing a bunch more pollen onto the stigmas when they visit. And so they're actually really effective pollinators. We also kind of measured like the difference in the visitation rates and looked at modeling that, like, sort of the probability of effectiveness given not just the amount of pollen deposited per visit, but also like over the average number of visits that each species makes, because it's true that the lesser long-nosed bats on average visit more times in a night, because they're fueling their whole metabolism off of nectar. But once you account for that, there's a little bit of spatial variation, but there are places in the Baja Peninsula where pallid bats are the more effective pollinator, and really a very reliable and consistent pollinator for the cardone cactus. So that's the main take-home message, and I hope that you've enjoyed this short video talking about 2 of my favorite bats and a little nectar feeding habit that leads to some neat natural history and unexpected results that sometimes mutualisms work out a little differently than how you think they're going to. All right, happy holidays, everybody.